Okay, part 3, the sun. We're going to just look at the sun in terms of an object in the sky and not really talk about what the sun is in terms of a star, nuclear fusion, and those other things. It really has to do with how we see the sun from the Earth, because the sun's position in the sky is really a function about how the Earth moves. Now, of course, we know the sun is the closest star to the Earth. This photo looks nice and yellow. In actuality, to our eye, it appears to be more white. Very, very important. Difficult to view the sun safely. Never look at the sun without proper protection because of the ultraviolet light that the sun gives off. In fact, during a solar eclipse, you can damage your eye because as the sun becomes occulted by the moon, the sunlight is still equally bright, but your iris opens up and you can burn your retina from this. So in terms of looking at the sun, you should only look at the sun if you have equipment that is specifically designed to protect the eyes. Okay? Unless you know what you're doing, never look at the sun, and certainly never look at the sun with binoculars or a telescope. You will damage your retina, and this damage is not repairable. Interesting features such as sunspots and prominences can be viewed when you have the correct equipment to view them safely. Of course, the sun is most interesting when we look at it during a solar eclipse. Now, when we look at the sky, we look at our imaginary celestial sphere. We have a celestial North Pole, a celestial South Pole, and we have a celestial equator. If the tilt of the Earth was 0 degrees, if as it went around the sun, the axis were perpendicular to its orbit, we wouldn't have seasons. And in fact, the sun would simply go around the sky as we went around it on the celestial equator. But we're well aware of the fact that the Earth is tilted by about 23 degrees. And as a result, instead of the sun moving around the nighttime sky, I shouldn't say the nighttime sky, moving around the sky on the celestial equator, it moves around on the ecliptic. Now, the ecliptic is important because that's where we have the not only the path of the sun, but the path of the planets. And if you're into horoscopes and all that crazy stuff, that's also where we have the zodiac. In fact, your horoscope sign goes back to an ancient tradition of astrology. This is astronomy, not astrology. This course is about astronomy. But if you studied astrology, the belief is that the position of the sun and the planets had an impact on your life. Now we know they don't have an impact on the fate of your life, but back in the day, they would believe that where the sun was in the sky, where the planets were in the sky, what constellation they were in would determine much of your traits and your fate. Today we basically just look at the sun sign, where the sun was when you were born. Where the sun is in the sky right now. We're pretty close to the winter. It's probably past Sagittarius now. But I was born in November, so my horoscope sign is Scorpius. The sun was in the constellation Scorpio when I was born. So there are 12 zodiac constellations, and your zodiac sign is based on where the sun was on the ecliptic the day you were born. Again, if we look at our solar system, the sun sits at the center of it. The planets basically orbit it almost on a plane, some more along the plane than others. And if we look at the nighttime sky, it's this plane which is really representing the ecliptic. Because all the planets orbit on the same plane, they, like the sun, also stick to the ecliptic. Now, we're sitting right here, so no matter where we look in the nighttime sky, we look toward the sun, we look toward the planets, we're looking pretty much along the ecliptic when we look in those directions. Axial tilt of the Earth. Again, the Earth is tilted. It's tilted by about 23 degrees. And in the winter time, the axis is tilted away from the sun, and this means that the northern hemisphere, at least winter for the northern hemisphere, we get less sunlight because the sun's not out as long, and also the angle of the sunlight is actually at a much greater angle. During the summertime, the northern hemisphere is tilted toward the sun, so we get longer days, more direct sunlight. Generally, it's warmer. But again, if we look at the axial tilt, the axis itself is pointing toward Polaris, and that's why the North Star, Polaris, never changes its position. No matter where we are in the sun, that axis is pointing in that direction. Now, let's talk about the solstice. The summer solstice, the axis, at least in the northern hemisphere, is pointed toward the sun. The winter solstice is pointed away. The reverse, of course, happens in the southern hemisphere. But again, the summer solstice, we look at our sky and we see that because of the way the ecliptic is tilted with respect to the equator, that puts the sun higher in the sky, at a higher angle in the sky. This is what it would be viewed from our location. And not only that, the path of the sun across the sky is longer. We get more daylight. So generally, during the summer solstice, it's the longest day of the year. It's approximately June 21st. It depends on the calendar. But that is when the sun is going to be out the longest. This year, the summer solstice is June 20th. It happens at 5:44 p.m. It is the longest day of the year. In terms of daylight at our particular location, it's 15 hours and 1 minute. Now, here's the strange thing. June 14th actually represents the earliest sunrise. Even though the sunrise is earliest at this day, the sun sets a little bit later than it does on the solstice. June 27th is the latest sunset. Okay? Now, some people are under the impression that it's warmer in the summertime because we're closer to the sun and cooler in the wintertime because we're further from the sun. No, completely about axial tilt. This proves it. In fact, on July 3rd, which is not far from the summer solstice in the northern hemisphere, on July 3rd, the Earth reaches its aphelion, means that we're furthest from the sun than at any other time of the year. So, the weather that we experience, the change in the temperatures, generally is due to the length of sunlight, the angle of the sunlight, we call the angle of insolation. It depends on the seasons. And again, here's what our Earth looks like during the northern hemisphere summer solstice. The Earth's axis is tilted toward the sun, so the northern hemisphere is getting more sunlight. The southern hemisphere is in winter, it's getting less sunlight. Winter solstice, approximately December 21st, the shortest day of the year. The winter solstice in 2020 happens on December 21st, 2012, at 5 p.m., 5:02 p.m. And shortest amount of daylight, only 9 hours and 20 minutes of daylight. December 7th was the earliest sunset. January 4th, the Earth reached perihelion, meaning that we're closest to the sun. But yet we know that January, at least in the northern hemisphere, well, north of the Tropic of Cancer, January is usually a very, very cold month. Winter solstice in the northern hemisphere, the axis is tilted away, still pointing toward Polaris, but because we're on the other side of the solar system, now less sunlight is getting to the northern hemisphere. If we could take the celestial hemisphere and sort of, spread it out like it was a map, we take a globe and we spread it out, like a plane. We notice during the summer solstice, the sun is in the highest part of the sky, It rises and sets north of east and west, and it does the opposite in the winter solstice. Okay? Notice, much longer arc, the sun is going to be up for a longer period of time. In the winter time, the sun is in the southern part of the sky. It rises south of east and sets south of west, and because the length of the arc is much less, it's not going to be up as much. Now, two other important points in the calendar are the equinoxes. The vernal equinox represents the beginning of spring. The autumnal equinox represents the beginning of fall. So when we look at this, we think daylight should be exactly 12 hours. During the equinox, it's actually a little bit longer than that, but that has due to a refraction effect in the size of the sun. But at this point, the sun is exactly on the celestial equator. The northern hemisphere, the southern hemisphere are getting an equal amount of daylight, and therefore we call this the equinox. The vernal equinox is March 19th, 2020 for the northern hemisphere. It happens at 11:50 p.m. Eastern Daylight Time. What is the vernal equinox for us is the autumnal equinox for the southern hemisphere. The autumnal equinox is September 22nd, 2020, 9:31 a.m. And this is what the Earth looks like during the equinox. Well, that's it for the sun. I'm going to end there. Our next video will be about the moon in the sky.